Okay, y'all, so today I'm going to discuss how to solve systems of equations by substitution by using the book. Okay, I'm not going to do all of these problems, so just follow along with me. Okay, so number 7, solve each system y equals 2x plus 6 and y equals negative 3x plus 16. So what I taught you in our lesson using the worksheets was that when you see y equals for both, set both of these equations equal to each other and solve for x. So I'm going to come over here to the side. 2x plus 6 equals negative 3x plus 16. Solve this equation for x. Your ultimate goal is to get x variable by itself on one side. So in order to keep all of my numbers positive, I'm wanting to add 3x to both sides. I'm picking my smaller number first and starting there. When I add 3x to both sides, I get 5x plus 6 equals 16. And then I'm going to subtract 6 from both sides. When I subtract 6 from both sides, I get 5x equals 10. Divide both sides by 5. When I divide both sides by 5, I get x equals 2. So the ordered pair of the point in which these two lines intersect is going to be where x is 2. How do I solve for y? Well, I can solve for y by taking that x equals 2 and substituting into either one of these equations. I'm going to pick the top equation only because it's easier than dealing with a negative. So I'm going to pick y equals 2 times x, where x is 2, plus 6. Y equals 4 plus 6, so y equals 10. Y equals 10. So the ordered pair where these two lines intersect is at 2, 10. 2, 10. Okay? Now for part B. Part B, I told you to don't bother with solving systems that are both in standard form. So I want you to go to Desmos, which I'm going to do it for you here, and type in this equation in Desmos, x plus y equals 8. And 3x plus 2y equals 14. Where do those two lines cross or intersect? They cross or intersect here at this point. If you click and hover, it'll give you the ordered pair. The ordered pair is negative 2, 10. So go back to your paper. The ordered pair is negative 2, 10. Okay, so for part C, you can solve algebraically because I have two equations written in slope-intercept form where I can set the two expressions equal to each other. Okay, so I'm going to scroll down on my paper here so I can have some room. Whoa, I just lost my space. I'm going to solve this. Let's see, what lesson am I in? Here we go. There we go. I can use this space here. I'm going to solve this system by setting both sides of the equation equal to each other. So 100 minus 2x equals 20 plus 6x. I'm going to start by adding 2x to both sides because this will have all of my numbers remain in positive status. So then I get 100 equals 20 plus 8x. Subtract 20 on both sides. When I subtract 20 on both sides, I'm left with 80 equals 8x. Divide 8 on both sides. I'm going through this pretty fast because by now you should be able to solve equations while you're sleeping. So x equals 10. So as an ordered pair, my x value is 10 for part C. For part C, x is 10. What is y? Which one of these equations would be the easiest to substitute in 10 for to solve for y? Well, in this case, it's really either one because 2 times 10 and 6 times 10, both of those are relatively easy. But I'm just going to pick the top one. Okay, I'm just going to pick the top one just to do it quickly. I'm going to replace 10. I'm going to replace x with 10. What's 2 times 10? 2 times 10 is 80. What's 100 minus 80? 20. 20. Okay? I just did something wrong somewhere. Oh, I got ahead of myself. That's incorrect. Sorry, y'all. I got ahead of myself here. Okay, 100 minus 20. Where's my pen at? 100 minus 20. What's 100 minus 20? 100 minus 20 is 80. The answer is 1080. I looked at my book to verify my answer and I was wrong. Okay, so 100, I did it in my head and got the answer was 80 and did 100 minus 80. But it's 100 minus 20 and 100 minus 20 is 80. Okay, and then part D, both equations are in standard form, and I'm not even bothering teaching you that because I don't want you to do standard form in algebra. Okay, so I want you to use Desmos here. I want you to use the graphing method, and more specifically, I want you to use Desmos. Okay, so the point at which both of these lines touch or intersect is at 2.51. 2.51. So on your paper, you'll go over here and you'll say, okay, they intersect at 2.51. Okay. Now we're going to scroll down and we are going to solve A and B together. So A and B, you have part A over here. I'm going to do right here. Part A, you have x plus 2y equals 8. And you have 3x minus 4y equals 4. Now, these are both in standard form, and I would like for you to use Desmos for these as well. But you know what? We're just going to use Desmos for these as well because they're both in standard form. So we're going to use Desmos for A and B also, just to make life easy, right? Just to make our life easier, because why make our life harder than what it should be when we have Desmos? Okay, so we're going to type in x plus 2y equals 8. We're going to type in 3x minus 4y equals 4. They cross and intersect at 4, 2. Positive 4, positive 2. So going back to our paper, positive 4, positive 2. Okay, part B, I'm going to type in the equations for you. 5x minus 2y equals 0. And then I'm going to type in 3x plus y equals negative 1. Where do they cross or intersect? Here. Now, these are as fractions in the book, but they're decimals in Desmos. So as a fraction, these numbers end up converting to, I'm going to write them as a fraction for you. But as a fraction, the value of these points is going to be negative 2 over 11 and negative 5 over 11. Now, I'm not going to put anything that crazy on your exam for you. Okay, I'm not going to put a decimal or a fraction as your coordinate of your intersection point. Okay, check your understanding. I believe this is the last part that I'm going to do with y'all. Yep, this is going to be a short video. So check your understanding. Okay, so on 13, both of these are in standard form. So again, I want you to use Desmos. Okay, I want you to use Desmos for 13. So x minus 5y equals 2. And x plus y equals 8. Those two lines cross or intersect at 7, 1. 7, 1. So on 13, I want you to write 7, 1. Now on 14, you can easily use substitution. Why? Because I have where x equals 2y. X is 2y. So x equals 2y. And I have x minus 7y equals 10. So I'm going to replace x with 2y. 2y minus 7y equals 10. 2y minus 7y is negative 5y equals 10. Divide both sides by negative 5. And I get that y equals negative 2. So I have y is negative 2. Y is negative 2. Well, how can I solve for x? Well, x is 2 times y. X is 2 times whatever y is. So x is going to be equal to negative 4. Okay? Now, number 15. I want you to follow along with me on number 15, because it's important that you know how to set up systems of equations, because you are going to have to set up a system of equations on your own on your test. Okay, so let's write down all the information that we know here. Theo buys a slice of pizza and a bottle of water for $3. Ralph buys 3 slices of pizza, and 2 bottles of water for $8. How much does a slice of pizza cost? Okay, well, let's write this down. First of all, we're going to say that X is going to represent pizza. And we're going to say that Y represents water. So X is pizza, Y is water. So let's write down everything that we know. Okay, so let's talk about Theo. Theo buys how many pieces of pizza? A slice of pizza. So one slice of pizza. So he buys 1 piece of pizza. And he buys how many water? He buys a bottle of water, which means 1. So he buys 1 water. And how much money did he spend altogether? He spent $3. So how can we write that as an expression? Well, we can say he bought 1 piece of pizza and he bought 1 bottle of water. That's a Y, for a total of $3. So X plus Y is $3. Then we can talk about Ralph. For Ralph buys 3 pieces of pizza. So he buys 3 pizzas. And he buys 2 bottles of water. 2 water. And he spends a total of $8. So we can write that expression as 3 pieces of pizza, so 3 times X, 2 bottles of water, 2 times Y, for $8. So now we have our system of equation. X plus Y equals 3, and 3X plus 2Y equals 8. So let's type this into Desmos and find the point in which those 2 lines intersect or cross. X plus Y equals 3. X plus Y equals 3. And then our other equation was 3X plus 2Y. 3X plus 2Y equals 8. They touch and intercross at 2, 1, at the point 2, 1. So going back to our problem, the intersection in which they cross is at 2, 1. Well, what does that mean? What can we interpret that into? What did X represent in our problem? X represented pizza. So how much was pizza? Pizza was $2. Y is 1. So what did Y represent in our problem? Y was water. So how much was water? $1. So the question is, how much does a slice of pizza cost? You would have to say pizza costs $2. Now you can verify that this answer is correct by just calculating and substituting back into the equation in the real world to see if it makes sense. If Theo bought 1 slice of pizza and a bottle of water and he spent $3, would that make sense? Yes. Pizza $2, water $1, 2 plus 1 is 3. Ralph bought 3 pieces of pizza and 2 bottles of water. So 3 pieces of pizza is 3 times 2, which is 6, and 2 times 1, which is 2, and 6 plus 2 is 8. So that's correct. So it satisfies both of our real world scenarios, which means that our point 2, 1 is correct, and the price of pizza being 2 and the price of water being $1 is also correct. Okay, so that sums up substitution. Again, I only want you to use substitution method if one variable is given, or if you can solve one of the equations for one of the variables, or if both of the expressions are written in slope-intercept form, where you just set the expressions equal to each other and solve for the variable x, and then substitute the value of x back into one of the equations to simplify for the variable y.